Assalamu alaikum. Welcome, dear students, to our third and last part in chapter 14, description of motion. By the end of this video, you will be able to define and determine the average acceleration and the instantaneous acceleration of a moving object. Let's start by reviewing together the main objectives of the previous videos. We've studied that a position vector determines the position of a particle m in a chosen reference, where r is equal to OM vector is equal to xi vector. The speed is the rate of change in position as a function of time. The average speed is the total distance divided by the total duration of time, whereas the instantaneous speed is the total distance traveled in a very short interval of time. The characteristics of the velocity vector are as follows: the origin, which is the position of the object at the given instant, the line of action, which is always along the trajectory, the direction in the direction of motion. If V positive, then the object moves in the positive direction of the axis, and if V negative, the object moves in the negative direction of the axis. The magnitude is the speed of the object at the considered instant. Let's start with our first objective, which is to define acceleration. Consider a race car starting from rest. This means that the initial speed of the car is V0 equal to 0 meter per second. After 2 seconds, this car reaches a speed of V1 equal to 10 meter per second. Acceleration is defined as the rate at which speed varies during time. But what does this actually mean? Average acceleration is the rate of the variation of the speed between any two instants ti and tj. It is given by A average between I and j is equal to delta v divided by delta t, which is equal to Vj minus Vi divided by Tj minus Ti. Now, let's go back to our previous example. The speed of this car increased by 10 meters per second in 2 seconds. Let's calculate its average acceleration. A between 0 and 1 is equal to delta V divided by delta T, which is equal to 10 divided by 2, which gives us 5 meters per second square. To understand the significance of the acceleration's unit, we ask ourselves the following. By how much does the car's speed increases each 1 second? 5 meters per second square is equal to 5 meters per second, which means that the speed of the car increases 5 meters per second in each second. As we've said, acceleration is the rate of change in speed during time. Observe the motion of the flying bee. Does it change its speed in a constant manner? Also, observe this car and note the way it changes its speed. In such cases, the acceleration differs from one instant to another. Thus, to study the rate of change of speed in a specific instant, you need to calculate its instantaneous acceleration, which differs from the average acceleration. Similarly to the way of calculating the instantaneous velocity, to calculate the instantaneous acceleration, we have to choose very small intervals of time. Instantaneous acceleration AI is the rate of the variation of the speed at a specific instant Ti. It is given by AI is equal to the average acceleration between the instant just before I and the instant just after I, which is equal to delta V divided by delta T. Note that to obtain the speeds in a very short intervals of time, we will use the recordings of the air table, where the time separating two consecutive positions is constant and equal to tau. Let's practice by solving application 1. Don't forget to pause the video and try to solve the application by yourself. To calculate the instantaneous acceleration of a car, we recorded the value of the speed indicated by the speedometer each 0.25 seconds. Note that 0.25 seconds is considered very short for the motion of a car, but it's not for a fly, for example. A fly changes its speed considerably in a duration shorter than this interval. In the first part, you are asked to calculate the average acceleration of the car between T0 and T3. A average between 0 and 3 is equal to delta V divided by delta T, which is equal to V3 minus V0 divided by T3 minus T0, which gives us 1.2 meter per second divided by 3 times 0.25 second. This gives us that the average acceleration between 0 and 3 is equal to 4.26 meter per second square. Now we need to calculate the acceleration of the car at T1. Which means that we need to calculate the instantaneous acceleration at the instant T1. The instantaneous acceleration is equal to the average acceleration between the instants just before 1 and just after 1, which is equal to A average for 0 and 2, which gives us delta V divided by delta T, which is equal to V2 minus V0 divided by T2 minus T0. then A1 is equal to 13 minus 10 divided by 2 tau, which gives us 6 meter per second square. Acceleration is also described as a vector quantity. It has a magnitude and direction. The acceleration vector of an object in rectilinear motion is given by the vector A is equal to AI vector. The characteristics of the acceleration vector in rectilinear motion are the origin, which is the position of the object at the given instant, the line of action, which is always along the trajectory, the direction will be discussed in the coming slides, and the magnitude, which is the acceleration of the object at the considered instant, which is equal to the norm of the vector A. Now, to discuss the direction of the acceleration vector, let's consider the case where the object moves in the positive sense of the axis. If the object's speed increases, then the motion is said to be accelerated motion, where V final is greater than V initial, which implies that delta V is positive, and this means that the acceleration is positive. Now, let's represent the velocity and acceleration vectors. The velocity vector is always drawn in the direction of motion. And since the acceleration is positive, then the acceleration vector had the same direction as the direction of motion. Then, in this case, A and V have the same directions. Now, the object is still moving in the positive direction, but the object's speed is decreasing. Then the motion is said to be decelerated motion, where V final is smaller than V initial. This implies that delta V is negative, and the acceleration is then negative. Also, as we've mentioned, the velocity vector is always drawn in the direction of motion. But since A is negative, then it is directed opposite to the direction of motion. Observe how, in this case, B and A have opposite directions. In the case where the object moves in the negative direction of the axis, when the speed increases in the negative direction, the motion is said to be accelerated, and the velocity vector and the acceleration vector will have the same directions, which is the direction of motion. Whereas if the speed decreases in the negative direction, the motion is said to be decelerated, and the velocity vector and the acceleration vector will have opposite directions. V is always directed in the direction of motion, and A in this case will be directed in a direction opposite to the direction of motion. Let's practice now by solving application 2. Don't forget to pause the video and try to solve the application by yourself. The figure below represents the motion of a puck drawn to real scale, where tau is equal to 60 milliseconds. Tau is the time interval between two consecutive positions. Note that real scale means that you can measure the distances using a ruler. In our case, the distances were measured and indicated on the figure to make our work easier. In the first part, you are asked to calculate V2, V3, and V4. Remember, V2 is equal to the average speed between the instants just before 2 and just after 2. It is equal to VAV between 1 and 3, which is equal to the distance between the positions M1 and M3 divided by 2 tau. 1.2 from the figure plus 1.8 divided by 120 milliseconds. We can convert from centimeter to millimeter and leave the duration of time in milliseconds. In this case, we can obtain the unit directly in meter per second, which gives us that V2 is equal to 0.25 meter per second. Similarly, V3 will be equal to 0.35 meter per second, and try the calculation by yourself, and V4 is equal to 0.45 meter per second. In the second part, you are asked to deduce the nature of motion. First, the trajectory is a straight line, which means that the motion is a rectilinear motion, and the speed was increasing from 0.25 to 0.35, etc. Then it is rectilinear accelerated motion. In the third part, you are asked to give the characteristics of the velocity vector V3 at the position M3 and represent it. The origin of V3 is the position M3, the line of action is the horizontal axis, the direction is with the direction of motion, which means that it is to the right, and the magnitude is the norm of the vector V3, which is the speed at the instant 3, which is equal to 0.35 meter per second. To represent it, consider the scale. Each 1 centimeter is equal to 0.35 meter per second. Then we will draw V3 at M3 directed to the right of length 1 centimeter. Now you are asked to calculate the acceleration at the position M3. The instantaneous acceleration A3 is equal to the average acceleration between the instants 2 and 4, which is equal to delta V divided by delta T, which is equal to V4 minus V2 divided by 2 tau. We have previously calculated V4 and V2, then we replace them by their values, which gives us 0.45 minus 0.25 meter per second divided by 120 millisecond. Now you should convert from millisecond to second, which gives us by dividing by 10 to the power 3, which gives us 0.2 divided by 0.12, which is equal to 1.6 bar meter per second square. Finally, you are asked to give the characteristics of the acceleration vector A3 at the position M3 and represent it. The origin of A3 is the position M3, the line of action is the horizontal axis. Direction, since it is an accelerated motion, then it is directed with the direction of motion. The magnitude of A3 was calculated to be 1.6 bar meter per second square. To represent it, we need to take a scale. We will consider that each 1 centimeter is equal to 2 meter per second square. By applying the cross multiplication rule, we obtain 0.8 centimeter. Now we will draw A3 at M3 directed to the right with the direction of motion since it is an accelerated motion and of length 0.8 centimeters. Now let's summarize the ideas of this video. We have studied that acceleration is the rate of change in speed as a function of time. Average acceleration is equal to delta V divided by delta T. Instantaneous acceleration is equal to delta V divided by a very short interval of time. The characteristics of the acceleration vector are the origin, which is the position of the object at the given instant, the line of action, which is always along the trajectory, the magnitude, which is the acceleration of the object at the considered instant, the direction, with the direction of motion in the case of increasing speed, accelerated motion, and opposite to the direction of motion in case of decreasing speed, decelerated motion. In other words, with respect to the direction of acceleration vector, if the speed is increasing, then the acceleration is with the direction of motion, which means that A dot V is always positive. Whereas if the speed is decreasing, then the acceleration is drawn opposite to the direction of motion, which means that A dot V is always negative. This is the end of part 3. Thanks for your attention.